everyone. Welcome to Big Boy Physics. Today I'll be talking about a problem which I posted many days ago in the community post, that is the ball on the gauze. Well, I also mentioned the source from which I took the problem, and I mentioned the details about what's the problem about. So the question says that you have a ball of radius r, that is capital R equals to 1 meter, and mass m is equals to 1 kg, placed at the horizontal net, which can be modeled as an infinite uniform rectangular grid with the cell size A is equals to 1 millimeter. The material of the net stretches according to the Hooke's law, which can be modeled as two closest neighboring points of the grids connected to a small spring of coefficient of stiffness k. Well, k is basically is the spring constant. They have written it as coefficient of stiffness. Nothing to get confused about it. Now they are asking me to estimate the value of k. It is known that the ball is immersed into the net under the effect of gravity, and they have also given us to assume that initially mass is not stressed, and under the weight of the ball its profile is kept everywhere horizontal except the region in contact with the sphere. It means this statement basically says that only the region as shown, this is my wire mesh, I am marking with red color, this is the wire mesh, and after putting the ball it depresses by some height h, and the wire mesh takes a form like this. Basically it will form a part of a sphere. Now, rather than a whole sphere, it will form a part of a sphere which is basically depressed due to the ball. Okay, so I hope you tried this problem. Let's get started. When I posted this problem, I also provided you a concept video on regarding the potential energy of a 2D mesh. You can check the video. I probably kept it under the playlist, so you may check it. I have said that the potential energy of a 2D mesh is given as k, where k is the stiffness constant or coefficient of stiffness of a single spring, into root sf square, sf minus root si whole square. Okay, so this is given as the change in potential energy, right? I also linked about a bit of surface tensor in that video. You can check it. So basically the change in potential energy will be k times root sf minus root si whole square. I hope it's clear. What we will do that we are generally asked to find a estimate. Actually, it's asking me to get the estimate, so I can equate delta U due to the spring mesh or the 2D mesh is equivalent or equal to the delta U due to gravitational potential energy, that is delta UG. So this relation will be sufficient to get a rough estimate about the spring constant. Another thing you can do is that find the force due to the spring by del u by del r or del u by del h, whatever you say. So del u by del h will give you the force, and then equating with it with the mg factor, you will also get that. Though there may be difference in the factor, that is the prefactor of the expressions, but the order will probably mostly remain the same. So nothing to worry about it. Another concept, small concept, I'd like you to derive actually, that if you have a sphere, suppose this is my sphere and it has radius capital R, and you cut out a section from it. I'm showing with the white color. So this is my required section. Then the surface area of this cap, which we call the non-hemispherical cap or any cap, is given as 2 pi rh. The surface area is given as 2 pi rh, where h is the distance between the tip of the cap and the base. Okay, so this is a result you can prove, and it's a very interesting result, right? So now let's get back to the problem. What will be my del u? Del u is equals to k times root sf. What is root sf? 2 pi rh, root 2 pi rh. What is root si? Now what is the radius of this circle? Radius of the base circle is small r, which is given as under root r square minus r minus h whole square. It will come out to be root h into 2r minus h. So basically the initial area root si, that is si is equals to pi r by small r square, which will evaluate to get root 2 pi rh minus pi h square whole square. Next, taking the root 2 pi rh common, you will get something like 1 minus under root 1 minus h by 2r whole square. Taking this out using the binomial approximation theorems, putting it as k into 2 pi rh into 1 minus h by 4r whole square, which you will eventually get to be 2 pi rh into k into h square by 16 r square. Finally you will end up with um, k pi h cube by 8r. So this is basically my change in the potential energy due to spring. Okay, now the gain in potential energy will be compensated by the loss in potential energy due to gravitation. So it will be equal to mgh, cancelling out the h, and you'll get k to be 8 mgr by pi h square, and that's the answer. Well, you can put the numeric values and other stuffs to get the approximate order. Okay, so comment me in below that whether you got this correct or not. Hope you enjoyed this video. Thank you and have a nice day.